Kia ora Year 12, and here's today's holiday video. I'm going to do two very old binomial problems that I found from the 1970s. They're both things that I think could pop up in Cambridge. The second one is probably in some ways more like an AS question than an A-level question, but it's still, I think, useful revision for us. So grab pen and paper and have a go at them first, and I'm going to work through them really slowly. Just when you're doing the first question, try and keep your working really, really neat. Because it will help you avoid mistakes as usual. Okay, so the first step with our first question is to rewrite this expression using a negative power. So we get 2 minus x times 1 plus x to the negative a half. So let's now do that binomial expansion. Sorry about the bass guitar in the background, but I can't help it. Right, so working very carefully here, we're going to have 1 plus negative a half x plus the next term. Right, make sure you don't do any of these in your head, even if you think you can. Okay, just don't do it. Right, so there we go. And I'm going to go to the next term because that'll give me 4. Let's see if I can squeeze it in. So we get negative a half, negative 3 over 2 times negative 5 over 2 over 3 factorial x cubed dot dot dot. So you know you'll get that on the formula sheet, but if you need to use it, you haven't done enough practice. So we're now going to expand that in 2 bits. Right, so we're going to have 2 times 1 minus a half x plus, carefully working through the fractions, 3/8 x squared minus 15 divided by 8 times 6 x cubed dot dot dot. Now at this point I'm going to simplify that last fraction so I don't muck that up. We'll take out a common factor here of 3, so we've got 5 here and we've got 2 here. That's the first bit, minus x times that right, so far I've just written it out in our usual way. What I'm going to do next is I'm going to line up using place value the degree of each term. Okay, so the first one I'm going to have 2 minus x plus 3/4 x squared minus 5/8 x cubed dot dot dot, and then underneath I'm going to do this expansion. So I'm going to put that first term there as minus x. Then the next one will be plus 1/2 x squared minus 3/8 x cubed. Now I'm not going to bother with this last one because I know that I just have to go as far as 4 terms. Right, so my answer here is going to equal 2 minus 2x plus, right, adding up these, 5 over 4 x squared minus x cubed. So that's my first, that is my first 4 terms of the expansion. Okay, now on to the next one. Right, so we're asked to find the term independent of x in this expansion. There are 2 ways to go here. The most obvious way is just to blast through it and do the binomial expansion. Okay, so I'm going to do that way first because it's not actually that bad, it's only to the power of 6. And we're looking for the one where we have x to the power of 0. So we'll start with x squared to the power of 6 plus 6c1 so you can see I'm up to here and I've got a few more to go, so I'm starting to get closer now. So 6c3, we don't care about the value of that just yet. That's going to give me x to the power of 6, and this one's not going to balance it out, but the next one is. I'm going to have x squared times 1 over x to the power of 4. So you can see what's going on in here. I've got that and that. So I don't need to keep going. I'm just going to put dot, dot, dot. And then the term that is independent of x is just 6c4, which works out to be, remember, 6 factorial over 4 factorial, 2 factorial, which is 6 5s over 2, which is 15. Okay, so that's fine. But what if we'd been asked to do one that was to the power of 23? That would have been really bad. So in AS, you probably learnt a general form for a term in a binomial expansion, and we're going to go over that on the next slide, just in case you forgot. Right, so the general term in a binomial expansion is this: t r plus 1 is going to equal n choose r times this, x to the n minus r, a to the r. So that's for the expansion, I should have put this, of x plus a to the power of n. So in our case, what we want is we're going to have 6, n is 6, r we don't know, and x here is x squared to the power of 6 minus r, and a is going to be 1 over x to the power of r. So we can manipulate the middle bit a little, and we get x to the power of 12 minus 2r. This is x to the negative r, so it's take away r again. And we want to solve for r. We require 12 minus 3r to equal 0, so r equals 4. Which means that the fifth term in the sequence is going to give me 6 choose r, and then it will be x squared to the power of 2, 1 over x to the power of 4, which is what we found the long way. Right, and so we get 15 again. Alright, thanks for watching. Remember, there's all the A-level binomial stuff is quite early in the book, so just make sure you've gone over it.